a very long time. For example, our solar system has been around for about 4.5 billion years, and who knows what was before that and what will come after. So this black hole is probably still there. It might not look the same as this image that we're taking here, but we have pretty good evidence that it's probably still going strong.
Yeah, we have a lot of people in the audience today, and I'm sure they're interested. If they go outside this evening, where would they look in the sky generally to where this galaxy is in this black hole?
So in order to find this galaxy, you'll have to look at the constellation Virgo. And Virgo will rise a little later tonight. So you'll have to wait until well after dark in order to do this tonight. A lot of people can recognize the Big Dipper in the sky. And so look for that pattern of 4 stars in kind of a square and then 3 stars in a curved handle in the sky. That'll be your tool for finding this part of the sky. It's really useful for finding other things too. So that curved handle will arc to the bright star Arcturus and then just keep going and spike down to the bright star Spica, which is in the constellation Virgo. That'll get you in the right part of the sky for seeing this galaxy.
Okay, so black holes for a long time were theory, and part of the theory is time travel. So will black holes allow us to travel through time?
So time and space are inextricably linked. Space-time is one entity in our universe. And what we see when we look at the black hole is we're seeing relativistic effects, which is what you get when things are moving close to the speed of light. And all sorts of weird things that start to happen to both space and time. The way that light is bent around the black hole is very weird and very cool. And it also has effects on time. For example, if you fell into the black hole and I was watching you and you were like shining a light back at me, as you got closer and closer to the black hole, aside from being in a very hot environment with lots of radiation and all sorts of, and being in space and everything, you wouldn't actually notice anything special necessarily as you cross the event horizon. But from my point of view, I would see you move slower and slower, and the light from you would get redder and redder. So it's a kind of a way of time travel when you get close to these very strong gravity fields. But sometimes people also talk about wormholes. Are black holes wormholes? Now, wormholes are kind of a mathematical idea, and they might exist, but we don't know yet. What I can tell when I study the data from the black holes is that they get heavier over time. Like this giant one, this one in the center of M87, it weighs more than 6 billion times as much as the sun. And you make a black hole when you collapse a star, but no star is that big. The only way it got that big was by swallowing other stars, gas clouds, other black holes, things like that, to get bigger over time. That mass is still there in whatever weird, twisted form we don't necessarily understand yet, but it hasn't gone anywhere else.
Becca, what would happen if you put a human through a black hole?
We wouldn't know. We'd never get a signal back. We would probably never ever find out unless they found a way to get out of it or to signal back to us. But of course we found out that nothing can escape it, even light, and the way we communicate is with light, with radio waves. So we probably wouldn't know anytime soon. So unfortunately, we're probably not going to go into any black holes, but studying them from far can tell us a lot more about their physics and these relativistic effects, which can then help us theorize more of these ideas in the future.
I heard about spaghettification.
Oh, yes.
And so I could be really thin?
Yes, as you fall towards the black hole, from our perspective, it'll look like you've strung out into like literally your atoms, the smallest particle of you, and it'll look like you're a long line of spaghetti. So that is an actual scientific word, spaghettification.
That will be a word I remember. Why is this image so important?
So to me, a big part of why it's so important is, like, look at everyone who's here. We think black holes are cool. Black holes really resonate with people. They're such a weird and marvelous phenomenon that people just like them. And so getting to see an actual picture of one for the first time ever is, I think, just by itself, really cool. I think everyone can kind of appreciate that. But it can also help us test our theories. So we have all these theories and simulations and artists' conceptions of what a black hole would look like, what's happening inside it, how does Einstein's relativity interact with, say, gravity and interact with quantum mechanics. But the